good evening, everybody. Thank you for joining us this evening. So really happy to be able to introduce my colleague Farhad Fasihi tonight to talk to you about systematic innovation. Before we start the presentation, I've just got a few comments for you, a few slides to go through and to give other people a chance to join us. So just some notes on kind of behaviour tonight. So while the talk's on, if you can ensure you've got your microphone on mute. We did have a discussion actually, if you want to leave your video on, that's fine. But equally, if you want to keep it off, then that's okay too. If you want to ask questions, can you please, if you just put them in the chat, and we'll come to questions later on in the evening. So just some general etiquette then. So be aware of others, be welcoming and respectful, be understanding of differences, be friendly and patient, be open to all questions and viewpoints, and be kind and considerate to others. Okay, thank you. So we like to kind of get an idea of who's here this evening and why you've come, so that we can improve things in the future. So we have, those of you that have been before would have seen this before. It's a quick questionnaire that we would like you to fill in if possible. So you can either scan the QR code or there's the URL at the bottom as well. The responses are anonymous, and it's just purely so we can understand who our audience are and to make sure that we're providing for you well. So for those of you that are new to the branch, new to the BCS, you can go to our branch website to find out some more information about us and if you want to join us. So we've got our aims, information about who the committee are, and upcoming and past events are on there as well. And you can also follow our LinkedIn group, which is BCS Nottingham and Derby. And a quick plug for next month's webinar, which is by Alistair Marvin. Now, Alistair's been with us before in person a few years ago, and he's coming to talk to us about authoring natural language requirements with ears. And that's on the 21st of June. So make a note in your diary for that one. And finally, before we move over to Farhad, we have a branch committee meeting on the 7th of June from 7 o'clock. It's online. And if you want to join that, then you should have received an email. If you're a branch member, you should have received an email within it. If you're not a member and you want to join us, then just put a message in the chat and we'll pick that up and send you some joining instructions for that. Okay, so finally then, so I hope you enjoy this evening. We will get to questions later on, and yep, and hopefully you'll enjoy it. Okay, so I'll pass over to Farhad to share his screen.
Thank you, Bev. Let me try and share my screen. Do you have my screen?
Yes, yep.
That's great. Okay, thank you, Bev. Good afternoon, everybody. Thank you for taking the time to join us for this session, especially on the first day that you've broken free from some of the COVID restrictions. I hope you enjoy this session and find it informative. A brief introduction about myself to put things into perspective. I'm an engineer by education with over 35 years in industry, academia, and business and commerce. I'm currently spending half of my time managing a small IT and communication company in Loughborough, with the rest being spent at the computer science department of the Nottingham Trent University. The common theme running through my career, both when I was at university and that of my business, has been innovation. I've been particularly interested in systematic innovation. As a result of that, in 2018, I set up a systematic innovation special interest group within the IEEE UK and Ireland, which I'm a senior member. And of course, I've been pursuing development of systematic innovation and its promotion as part of my activities outside university and in relation to IEEE. I'm going to give you an observation based on my experience since I left university nearly 40 years ago. I feel that today we're facing huge problems as a human race, which when I compare it with what we were facing at the time of my first graduation, it seems as if things are getting much worse. Despite our impressive technological advances, I'm sure we've made mistakes along the way, which has been compounded by depreciation of resources and population growth. Environment was never as big a problem as it is today. Poverty, hunger, disease, mobility are some of those critical problems that we are facing today, which need better solutions. And of course, as systems have been one of the foundations of the progresses that we made in industry and in science, I think systematic innovation could play the same role. That is why this is the subject of our discussion today, and I try to share some of my thoughts with you in due course. Now, our agenda today is that I give you an introduction. I talk about the well-known systematic innovation models that include phase or Stagegate, TRIZ, design thinking, Scamper, and systematic inventive thinking, or SIT. Now, talking about these methodologies will give us the opportunity to look at the potential future development and what could be our way forward. The key concepts I think we need to sort of bring everybody online is that there are different definitions for innovation. When you're talking to various people, they have different ideas. You look into different dictionaries, you will find different definitions with different nuances. Apart from discovery, which has got some sort of serendipity attached to it, we've got creative problem solving, which is usually refers to a unique situation where you are trying to solve a problem in a particular situation. To give you an example, and a silly one as that, if you did not have cooking facilities at home and you wanted to cook an egg on your way home from the office, you might open the bonnet and place your egg somewhere which gets heat, and hopefully by the time you get home you have an egg that is ready to consume. Now, this is potentially a creative problem solving approach. Now, invention, you get that when you decide that it is too much of a hassle to open the bonnet and find a place which might not be clean. You decide to develop a gadget that enables you to cook that egg, perhaps somewhere inside the vehicle, and that turns into an invention. And of course, when you look at the market and you find that there are so many other people who may have the same problem as yourself, that might trigger innovation. Of course, it is important to mention that neither the area that you are working on nor the technology that you are deploying has any bearing on whether an invention can turn into innovation. The examples are clear, looking at Sinclair C5, which was so far ahead of its time, but still, because it could not become a commercial success, that remains an invention at best. By contrast, Fruby toy, which came to prominence during the 90s, and in a short few years they managed to sell 40 million of these little fluffy toys, is a true commercial success, and hence can be considered as innovation, regardless of the fact that in terms of technologies that were utilized is nowhere near what Sinclair produced. We've got different types of innovation. I've even seen up to 10 different categories. I prefer to stick to these three definitions, which happens to be the British government's definitions as well. Step or incremental innovation, which is majority, over 90% of innovation, is sort of follows incremental steps, small steps, and improve the original idea. Drastic or breakthrough innovation is a situation where a new idea comes and revolutionizes the approach and makes its predecessor obsolete. An example is the electronic calculator that replaced abacus and slide rules. Some of you might still remember slide rules from your university days. I certainly remember how difficult it was and how easy it is to use a calculator now. And of course, disruptive innovation is something that changes the whole setup, the performance, the attributes, price, and of course, more importantly, the customer's expectation from the new development. An obvious example is a smartphone, which changed the mobile phone industry. Let's look at the systematic innovation models and their heritage. Phase or Stagegate was first introduced during the 1940s. TRIZ, which is the Russian acronym for inventive problem solving, was introduced again during the 1940s. I think it was 1946 that came out first. Design thinking, 1950s and 1960s. Scamper, which is again an acronym around the same sort of time, and systematic inventive thinking, which was a subset of TRIZ, was introduced around the 1990s. Let's look at a different one of these. Phasegate or Stagegate was initially started as a project management tool, but soon it was realized that it had more potential. essentially, it's suitable for managing large infrastructure projects and what it was initially designed for. It is financially biased. Again, we can see that accountants rule engineers. It is based on a stage development process, and of course, the number of stages are flexible. And of course, you've got multiple assessment outcomes, which could be go, abort, hold, rework, and anything else that you may think of. What you can describe it is as a path where you've got to clear different staging posts before you move on to the next stage. This is how it appears if we were to draw a diagram. It starts from the idea and to the end, whether it is a new innovation or managing a large complex construction. You've got different phases, which may be as scoping, business case building, development, validation, launch, or anything else that you may see fit. Each phase is followed by a gate, which whose example could be evaluating strategic value or viability or the feasibility, risk and return, and so forth. So this is how things will look when you're considering phase gate, and you will notice as we go forward that this staged approach or stepped approach has been taken up by others in the wake of this particular approach. As I said, this is the acronym for Theory of Inventive Problem Solving. It was created by a Russian called Genrikh Altshuler in Russia around 1946. It is based on analyzing patents. Genrikh was an engineer working in the Naval Patent Office, and he got interested in the patterns that was emerging when he was studying the patents he was dealing with. He realized that innovative steps you follow certain paths, and there are infinite numbers that he can actually spot when he studies these. He attempted to map these common features and found the patterns among those patents. He started introducing principles, tools, and techniques based on what he studied there. The principles that he identified were 5 IFR, or ideal final result, which effectively says that delivering positive improvement against negative consequences and the cost of change. So whatever you do, you have to make sure that you meet this criteria. Contradiction, again, he realized that most patents were trying to solve contradictions, and those who managed to solve these contradictions were more successful. An example being that if you are trying to make a faster car, you often need to make the car engine bigger. But if you wanted to have a faster car and more environmentally friendly, the more capacity you build in the engine, the higher would be the pollution. So these two contradict each other, and what this principle says that if you can manage to solve these contradictions, you get a better outcome. Functionality tries to focus attention to solving one problem at a time. So what it's saying is, if you are trying to solve a problem, target a single function and any part of the solution that does not contribute directly to what you're trying to resolve is potentially unnecessary and should be eliminated where possible. Use of resources, sustainability has always been an issue. It's not something new. So he discovered that in about 70 years ago, and we are still dealing with sustainability issues. Space-time interface is essentially tells innovators to make sure that problems should be looked at from different angles to ensure that they are fully understood before they can be responded to, and you find appropriate solutions. He identified 40 techniques. So if you follow those principles, he started to look for things that were common and classified them under these techniques. Segmentation, extraction, local quality, symmetry, and the list goes on. Some of these are difficult to understand purely because they are translation of a Russian word, but some of them are a fairly old concept. For instance, if you look at 29, pneumatic or hydraulic construction, I don't think it is too often that we see that sort of words appearing in patent applications these days, because we have moved on from those technologies. But one thing is significant here is the fact that he managed to find different, if you like, strands that had similarities and things in common. So we need to bear this in mind for future. TRIZ is difficult to apply because it relies on a particular approach, which you need to, first of all, identify your challenge, what problem you're trying to solve. And of course, you need to apply the principles that you've learned about. Then using abstraction techniques, you need to turn it into one of the universal TRIZ generic problems, and then again apply the tools, principles, and techniques offered as part of TRIZ to solve it in and arrive at the conceptual specific solution that TRIZ recommends or highlights, and then you have to apply it to your own set of circumstances and find the specific solution that you need to look for. Now, again, I've spoken to people that find this a bit difficult to understand. I want to give you an experience, an example from my experience, which may help understanding this. The first job I had after my graduation as an electronics engineer was working in the control rooms of a tank farm in a refinery. Of course, I was dealing with boards and circuits and control panels, and I didn't know what was happening in terms of process and chemistry. I once asked a senior process engineer to seek some explanation to understand what was going on in the background, and he told me that basically oil refining is a combination of separation, conversion, and treatment. So he said, we use heat, we use pressure, and we use chemical reaction to separate the material. And if you look at this this tower here, we heat the crude oil at one end, and it comes and different molecules will separate based on their weight. The gases will go to top and pressurize, and of course we start getting different material at different stages of temperature and pressure. So if you consider separation, conversion, or treatment as one of the generic principles, what you are effectively saying is, if you have crude oil and you want to get a new material with certain characteristics, it should follow this pattern. Now, what are the special conditions? Then you need to work those out. So that is part of the innovator's remit. Design thinking is another popular systematic process. It was initially developed as an end-user centric product development with emphasis on empathy rather than sympathy with user and their needs. So, but it soon became apparent that this is a very effective tool for innovation. It follows a holistic approach and a systematic process. It is iterative in its nature, and it relies on repetitious steps. It is particularly suitable for small product developments if you are looking at it as a product development tool, but you can utilize it for larger innovations as well, utilizing certain tools. It is primarily experimental, and culture of prototyping is prominent when you are dealing with product development. It values user feedback. Show, don't tell culture is something that rely on heavily. So what we are having to deal with here, if we were to model this, we have to empathize with the user and their need. And of course, it is important to note that empathy is totally different from sympathy. Sympathy suggests that you are looking at a problem from a higher plane, whilst when you're empathizing with a problem and the user, you actually have to feel and live their situation. Once you've empathized with the problem and the user, you then define the problem. Once you've defined, you go through the ideation process, you prototype, you test, and you measure, you redefine, you ideate again, do the prototyping again, and so forth until you get to what you are expecting. Those of you who are involved with user experience design and user experience research would recognize this double diamond, which is part of the design thinking. What we have is discover, define, develop, and deliver. When we start, we diverge when we do the primary research, secondary research, and then we start converging again as we define the opportunity and the problem, and then we diverge again when we start thinking about different ideas and how we can solve the problem, and then begin to converge again before we get to the final solution. Scamper, as I said, is an acronym made up of different innovation strategies. It relies on asking directed questions. It is a still version of an original 10-point system, which was introduced by Alex Osborne, who has got lots of contributions to neuroscience, psychology, and indeed to innovation and how brain works in these areas. Substitute, again, material, part, or resources can be changed to improve the product. Combine, put things together. For instance, if you've got a bicycle, you put an engine on it and you turn it into a motorcycle. Adapt, you can sort of adapt different products for different uses in new context. Modify or magnify, again, you can emphasize different parts of same design, use the same product for a different purpose. Eliminate or minify, remove some parts of the system, or rearrange or reverse. Again, you can use these strategies to come up with new ideas. For instance, if you've got a scooter, an electric scooter, rearrange the position of the wheels, and you could come up with Segway. There are multiple examples that you could look and find how these strategies can be adopted. SIT is systematic inventive thinking. It is essentially the lighter version of TRIZ. The reason it being is the two guys that created this were part of the research team that was put together by the original TRIZ developer, and in late 80s, early 90s, they left Russia to Israel, and they took away some of the things that they have learned when they were working on TRIZ. They realized that TRIZ could have been perceived as difficult by some quarters and old-fashioned by some others. My personal view is that probably if TRIZ was developed in anywhere other than Russia, it might have had a much better reception and could have been developed much faster and better. But anyhow, these guys started thinking about removing some of the complexity, making it simple. That is why SIT is referred to as TRIZ Lite. They came up with some buzzwords and some principles that was slightly different from those of TRIZ. Think inside the box, opposite to thinking outside the box when we refer to innovation. They said that in view of the fact that most innovation is incremental in small steps, you probably have all you need at your hand, and you better focus on the building blocks around you when you are thinking about innovating. In other words, they acknowledge the difficulties that you may have and the restrictions that may apply to the area that you are working in. Function follows form. Now, I have always heard before that form follows function, but these guys are saying that not only form follows function, function follows form as well. So effectively turning things on its head. And what they are saying is instead of trying to follow the market demand, see where you can actually use the existing solution. They also presented the qualitative change as a principle that for always solution that can be identified at the heart of the problem and removing or eliminating those is going to lead to solution, but even better, turning those negative into positive could enhance the solution that you may come up with as a result of your effort. This next one I find interesting, path of most resistance. Of course, it says that usually we try to find the easiest way to solve problems, and that is why we end up somewhere down the line with further difficulties. They suggest that we should consider all paths, including the path of most resistance, and it is possible that we can come up with a better idea. Next one, again, is very important, cognitive fixedness. What we sometimes do, we are fixed with form and function. So if we are thinking about a particular object, for instance, a bicycle, we can often forget about anything else that could come out of the components of that bicycle, but something that we can ride on and get from A to B. What the cognitive fixedness tells us is that we should be able to consider all the elements of each construction and think about them separately, so that we are not fixed with what we have in mind as a perception about that particular object. Near-far suite, again, it promotes the adoption of ideas developed somewhere else, which is a common practice in innovation, but the emphasis that SIT places is that it should be close to core competency. The SIT methods, you can actually see subtraction, division, multiplication, tax unification, attribute dependencies. We've heard this before in Scamper and in TRIZ. This is much simpler, has produced 5 techniques that we should follow. If we summarize the systematic innovations that we looked at, we can see that they all follow a structured and staged approach, similar to Phasegate. They follow frameworks with philosophies, principles, and specific techniques to produce results. They primarily focus on inventive problem solving and varying complexity and ease of application. They're biased according to developers' field of expertise, knowledge, beliefs, and the attitude in the context of their time. And of course, one important common theme is that they are all process-centric, i.e. human element is considered as a constant. But also, as we mentioned, despite some of the differences, there are distinct similarities in their techniques, i.e. If you look at extraction in TRIZ, is the same as subtraction in SIT and elimination in Scamper. This gets us to what I consider our universal innovation process. It starts with desire, when we've got personal attributes drive us to want to do something, and then we start wondering about concepts. We spend dedication, otherwise we never get where we want to go, and then we identify a long list of challenges or opportunities. Once we apply domain knowledge and analysis, we turn that long list into a short list. We apply creativity and imagination to find potential solutions. We evaluate these solutions and apply some benchmarking, and we eliminate unviable solutions to come up with a potential list of viable solutions. So, before we apply our appraisal benchmarks to decide whether we want to proceed with this. And of course, this can go on and on and on. So if I was to redefine this, we can see that the whole process is consisted of creative and logical steps. If we look at the desire, we could say that it is probably half creative and logical, the same with wonder, the same with challenge identification or opportunity spotting. Analytics, probably primarily logical. Creativity, by definition, is primarily a creative step. Evaluation and appraisal are probably primarily logical. Although when we say something is primarily logical or primarily creative, it doesn't mean that it is devoid of the others. It's just that it is predominantly either creative, logical, or combination of both. Now let's take stock. What we have heard today, what we have considered, we need to look at the strength and the weaknesses. The strength of what we have looked at was the systematic approach has been the vehicle for all the previous developments. They've utilized proven knowledge, for example, patent as a systematic platform. And they've considered different variations and they've been developed based on the best knowledge available at the time. But the weaknesses of what we have seen is deficiency of the utilized knowledge platform. In this case, I refer to patent. Patents are solutions that were developed during the 15th century. It was an idea of safeguarding intellectual property. It was to protect money. Although it has been developed and has made to a new century, 21st century, in the form of online and databases, but the structure is still the same. It's got limitation of application in specific areas for specific type of questions. It is disconnected from developments in other areas, in particular new technologies such as AI and data analytics. This is a sample, a UK patent used here as an example. It has a purpose, which is protecting IPR. It is a structured legal document. It's got various elements to it and serves that purpose pretty well. But what we can deduct from this and how we can chart our way forward, what should be our objective? I would say that our objective should be to find a way to further enhance innovators' skill sets by utilizing current advances in technology. We should also promote innovation and creative problem solving across the society. And we have to develop and enhance new tools that can accelerate innovation process. Now, these are the objectives that we are following to consider what should come next. If I was to give you a blueprint for future systematic innovation, I would say that we need to get rid of patent as a vehicle, because it is something that has been designed for a different purpose. We need to develop language of innovation, an alternative method of defining innovation. We are used to developing different systematic tools and techniques. We've got symbols for data flow diagrams, flow charts, electrical processes, mechanical processes, all sorts. We recognize the fact that a symbol that is designed to identify an electronic component may not be useful when you are defining or designing a big manufacturing process. It requires different capabilities. When you are defining a data flow diagram, you know what you're talking about. But if you are talking about machines and how they sit and arrange on a shop floor, then you need different tools. We as engineers and scientists have learned that we need to have different tools that work at different areas. Yet we have, in my view, been stuck with patent as the basis for most of all these development. I think that needs to change. We need to develop a new language for innovation. And of course, that is the first point. Now, there are clearly differences between the principles and the tools and techniques that may be used, for instance, in computing compared to, I don't know, process engineering. So I think those tools and techniques should be clarified and designed. We need to design a compliant computing language, as we have done with AI and data analytics. Python and R comes to mind as two examples of how we decided that perhaps the general programming languages weren't sufficient for us to deal with the complexities of AI and dealing with large data. And of course, as part of that, we need to make sure that what comes at the end is a powerful tool that can be used by scientists, researchers, and of course, the public. What I consider prerequisite here is getting everybody involved. We need to capitalize on advances in AI and data science, and of course, the wisdom of all the stakeholders, whether it is scientific and research community, computing experts in particular, engineers, business researchers, lawyers, governments, and anybody else that may have an interest in this particular area. With this comment, I would like to bring this talk to an end, and thank you for bearing with me when I was giving this presentation. I'll be happy to answer some of your questions, and I hope to get some feedback from you and some comments that could help me and everybody else that may be listening to this conversation moving forward. Thank you, and I stop sharing and hand over to Bev.
Thank you very much, Fahad. That was really, really interesting. So we've had a couple of questions in the chat, so I'm going to hand on to Matt now, who's been monitoring them to go through them. And if you do have any more questions, we've got about 10 minutes, so just pop them in the chat.
Thank you, Bev. We've had a couple of questions so far. One from Paul. So this was earlier on, Fahad. Interesting that a technique developed by the old Soviet Union appeared here. Was this adopted by the West at the time?
At that time, it wasn't much that was developed. I think the departure of the two engineers to Israel opened up the rush to develop that further, and SIT was one way. But even when the SIT came out and people started to look at the predecessor, which was TRIZ, there are different groups that are working on that. I know of a group in Oxford called Oxford TRIZ, which again, they have gone through simplifying TRIZ original, not to the extent that SIT has sort of achieved to simplify it. Indeed, later in June, I have organized an introduction by Oxford TRIZ to come and introduce their approach, which is slightly softer version of the original TRIZ, but they have introduced new elements to it. One of those is trend. They have not only considered the principles which were a main part of that TRIZ, but what I was talking about, keeping sort of different strands going at the same time, they have started putting trends which links the different solutions or strategies to different industry. I will share the details of that webinar, which is organized by IEEE with BCS, so that those who have interest to learn more about this new Oxford TRIZ could actually attend that webinar as well.
Thank you for that. Another question, unfortunately, it was probably context to what you're speaking about at the time, but I'll ask the question. Would you say that this is a continuum of techniques, or does each one stand alone today to be used in a definitive set of use cases?
Well, I can say that it is something that when you talk to different people, they have different views. I've spoken to people that they think TRIZ is the best thing since sliced bread, whilst talking to somebody that applies the others. They think that they have the best solution at hand. The reality is that the truth is lies somewhere in between. Each one of them have some advantages and some disadvantages. For instance, SIT, I personally believe that has its advantage where it acknowledges the constraints that companies, organizations may be facing when they are trying to innovate. Obviously, some organizations have much bigger constraints. So when you are comparing somebody like Boeing with an SME in Mansfield, you will realize that they are in different leagues, and the solutions for these organizations could come from any one of these. It's in my view, they all have started from the same concept, with the same beliefs and aspirations. A lot of these, as you probably have seen, are continuation of previous attempts, but really how you apply it and to what degree of proficiency you apply those techniques is what determines what the outcomes look like. But my suggestion is that if you want to use any one of these, you need to learn and become sort of proficient in using it before you start seeing any benefits. They take time to master. You need to factor that into consideration. I know that Rolls-Royce has used TRIZ, and they had a team that was looking at TRIZ, which is no longer sort of using that. They've moved on to other areas. I think they've developed something based on some of those lessons. But the simple question is horses for courses. You need to choose your solution based on the problems that you are facing.
Thank you very much. We don't have any more questions. So thank you very much, Farhad. And thank you everybody for joining us this evening. Can I just remind you to complete the branch questionnaire, please? And the link to our next event is in the chat as well. So thank you very much, everybody.
Thank you, and have a good evening.